Okay, video 2 on chapter 20. We're going to go over the binomial distribution. What it means and how we use it was done on Thursday, but today we're going to look over some questions and how we apply it. Although we did 1 or 2 on Thursday, I just think we're going to do a couple from the review set. As always, if there's other ones you'd like me to do, please send them to me and I'll give them a go. But I've just picked a couple out, how many have I got here? 5 from the review set, and we're going to try to go through those. So, question 10 we actually covered on the previous video, but we didn't cover part C. So let's have a look what we found from part A and B from question 10 in the last video. So on part A and B, we found that the probability of red equaling 1 was that. And so in this case here, we've got 20 reds are rolled. And so let me just get some space. It's going to take a couple of space. This question. Here we go. Paste. Might even need some more space on that. Yeah, and so what the second question, or part C, is asking is state the distribution of x. So state the distribution of x, and then write down for x equals 1, p of x equals 1 and p of x equals 9 for the pair of spinners that are spun, where x is the number of times that red occurs. So that's what we did in the last video. We looked at the number of times that x occurs, or that red occurs, and for probability of red equals to 1, we got 11 over 20. So why is this binomial? So for a binomial experiment, let me just write this down. This is second part II. But part I asks us, what sort of distribution is it? And it's binomial. The reason being is that binomial is on a fixed number of trials. So let me write this down, binomial. And binomial is for a fixed number of trials. So in our case, how many trials do we have? We have 10 fixed trials. And because we know how many trials we're doing, that's one clear indicator. Another is that there are only 2 possible results, success or failure. Two possible results, let me write it down. Binomial is always success or failure. Success, which we've got as 11 over 20, and failure, which would be what's left over, 9 over 20. And then the final one is that the probability of success is the same for each trial. Probability of success is the same for each trial. And it depends how many marks on a mark scheme this is worth. If it's just worth 1, they're probably looking for binomial. If they want you to give a reason why, usually giving 1 of those is fine, but I think 2 is really the recommended. So you pick 2 of those really. First 2 are kind of stronger because the third one's kind of implied. So the second part of that question is saying, write down the expressions for x equals 1 and x equals 9. This is where our friend, the graphical calculator, comes in handy because, actually, can we do this without? I think we can even do this without. But in general, binomial theorem, you're going to tend to use a calculator. Well, we went over this in class, and when we went over this in class, we looked at the probability for binomial. And so the definition for probability for binomial, p of x equals x, is that you've got n choose x, lots of p to the power of x, or how many successes you've got, and then 1 minus p, which is your failure, to the power of n minus x. And we wrote that down because it comes from the a plus b to the n expansion, which we looked at when we did the binomial theorem. But in these cases here, my probability is 11 over 20, my number of trials is 10, and then they want p of x equals 1. which would be 10 choose 1, which is actually just 10. You could check that on your calculator though. But it's always, if you've got anything choose 1 or this number is 1 at the bottom, then it implies it's the above number, or it's just n. And so therefore probability is 11 over 20 to the power of 1 times 1 minus 11 over 20 to the power of 10 minus 1. Because we've got 9 failures, 1 success. And if we plug that into our calculator, either we can do it, we're going to use the calculator for another one. I think this is fairly simple because all we need to plug into our calculator is 10 lots of 11 over 20 times 9 over 20 to the power of 9. And that would give us I'm getting 0.00416. We don't need any more decimals than that. So 3 significant figures. It's good to put 3s dot f dot, and the other one was p of x equals 9. Very similar. 10 choose 9. I mean, the reason why 10 choose 9 is just 10 is, when we think about our Pascal's triangle as a side note, it goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. But anyways, this result here, for instance, is just 4 choose 1. And this one here is 4 choose 3. And so always the penultimate and the second value are just the number itself. So we're on the 4th row, so it'd just be 4. In this case, here we're on the 10th, so it'd just be 10. And that's why it's not really a calculator question for me. So 11 over 20 to the power of 9. Well, it is, a calculator, but it's not really one where you have to use the distribution and get all complex about it. To the power of 1. And so that's just 10 lots of 11 over 20 to the power of 9 times 9 over 20. And that gets me to as always, when you're doing stuff with the calculator, stuff takes time. Naught point naught 2072419, whatever. So all we need is 0.0207 to 3 significant figures. Okay, question 11. Ruben has an 80% chance of waking up early enough to get to school on time each weekday. That's fairly good. Let the x be the number of days that Ruben arrives to school on time over a 10-week-long term. Okay, straight away I'm spotting, what does 80 mean? Well, 80 is probability, and what does 10 mean? That's my fixed number of chance. And so there's really my p, and that's my n. So what are we working with? Binomial distribution with n equals 10, and our probability is 0.8. So that means x is binomially distributed with 10 trials and 8 probability, 0.8 probability. Okay, so calculate the mean. These are just definitions. So the mean, or mu, in our case is np, and so that's just 10 times 0.8, which is just 8. And then part B, what's our standard deviation? Also just the definition. It's the square root of, I think it's np 1 minus p, np 1 minus p, something like that. Let me just double check it. Let me go into your textbook and just double check it, but it's on a formula booklet. Just double checking, I don't want to make a mistake here. np times 1 minus p, and because the standard deviation is just sigma, we don't need sigma squared, and so therefore we square root it, and so that's the square root of np is 8, 1 minus p is 1 minus 0.8, so 8 times 0.2 is 1.6, and then the square root of 1.6. Should really do that in my head. 2 square root 10. Okay. Can always put stuff in decimals as well, but that's fine by me, giving it as an exact number. Okay, great. Next question we're going to work on is going to be, it's 10 weeks long. Have I incorporated 10 weeks long? Yes, I have. Number of days. Oh, okay, I see. I've made a mistake here. And my mistake is simply that 10 weeks long, I've taken that to be my value for n. In fact, it's the number of days. And so what I need to do is I need to do 10 times 7, I think. Because, weekdays. Well, there's only 5 weekdays, isn't there? So this is what I mean. Reading the question is so crucial because this is the number of days. Number of days. I thought it could be the number of weeks, but it's not. And it's school days. So it's only 5 school days on a weekday. So in fact, how many weekdays are there in a 10-week long period? Well, there'd be 5 times 10, 50. And so what's our mean going to be? Sorry, it's going to be 50 times. Okay, so I made a slight mistake there. So that's not on my value for n. And so therefore, we would get 40 here. And then if we do the other calculations here as well, we've got 40 lots here. And so that's the square root of 40 times 0.2. And so we just get the square root of 8. I mean, you can simplify the square root of 8 if you like down. It's like 2 point something. Okay, done. Question 13. It is observed that 3% of all batteries produced by a company are defective, so that means that 97% are not defective. So for a random sample of 20 batteries, calculate the probability that none are defective. So I'm going to take my probability of success is that the battery fails. You could do it the other way around as well, but that's what we're going to do. So we're going to do for part A, there's 20 batteries, so that means that X is binomially distributed with 20 batteries and 0.03 as a probability of success. So the probability that none are defective is the first term in our binomial. Nope, it'd be our last term in our binomial sequence. So that means that we need choose 20 lots of 0.303 to the power of 0 times 0.97 to the power of 20. And so 20 times 20 is just 20 over 20. 20 choose 20 is 1. So this is P of x equals 20. No, P of x equals 0 defective batteries. In this case here, it probably is easier to write it down as 0.97, but all we'd have to change here is that it'd be 20 choose 0 as the first term. Nothing else has changed. But 20 choose 0 is just 1, and so therefore it's just 0.97 to the power of 20. So 0.97 to the power of 20. Again, you could plug that into your calculator, but I think it's quicker just to type that straight in. So I get 0.544 to 3 d dot p dot. All significant figures. Okay. At least one is defective. At least one is defective. So at least one is defective. Again, you could put into your calculator P of x is greater than or equal to 1, and you could do it like that. And you just have to set your upper band to whatever your upper band is. But what we know is that if P of x is greater than or equal to 1, that's the same as 1 minus P of 0, because P of 0 is the only one that's not included. So this is exactly the same as 1 minus 0.555444, whatever. And so therefore we get 0.456, again to 3 decimal places. I'm doing quite well here actually without using that. Okay, let x be the number of defects in a random sample of n batteries. That was what x was before, wasn't it? Write down an expression for P of x equals 0. O for n number of batteries. So now we've got a binomial distribution of n number of batteries, and the probability that it's defective is 0.03, so of not defective is 0.97. So write down an expression for P of x equals 0 as that, so that means that P of x equals 0 in our case here is going to be n choose 0 of 0.97 to the power of n, and then 0.03 to the power of 0 because there's no defective ones, which is the same as 0.97 to the power of m. Part II. Calculate the smallest value of n such that P of x greater than or equal to 1 is greater than or equal to 0.3. Okay. So let's use exactly the same thing that we did before. So we know that that's the same as 1 minus P of x equals 0 because it's all the values apart from 0. So that's the same as 1 minus 0.97 to the power of n. And first of all, I'm going to find the critical point here, which is the point at which n for this function would mean that we get 0.3 out of here. And then once I've found that, I just need a bigger value for n so that I get my value for p that I want. So let's rearrange this. That means that 0.97 to the power of n equals 0.97. Or is it really that simple? It cannot be that simple. Oh, okay, yeah, I see my mistake. 0.70. It's going mad for a second there. And then I'm going to use logarithms. So first chapter we ever did, pretty much, this year, which is log 10 of 100 equals 2, because 10 squared equals 100. That's my rearrangement. So therefore I need log 0.97 of 0.7 equal to n. So log of put this into my calculator. I get 11. And so as I was saying, we need at least that number, so we need n equals 12 number of trials to get past that 0.3 probability. And we need a whole number for n because we're working with binomial and we're working with discrete And so because we're working with discrete random variables, 11.7 doesn't exist. Whereas it does in the normal distribution, which we will do shortly. Great. The spinner alongside is spun 20 times. Let x be the number of 3s spun. What's the probability of a 3? 1 out of 5, 0.2. Explain why x is binomial. Exactly the same reasons that I put up here. Let's copy them, and then let's just tailor them to the question. So y, we've got 20 fixed trials. What's the probability of success? In our case, it's 1 over 5. And failure is 4 over 5. And we know those are the only outcomes because they add up to 1. And then the probability of success is the same for each trial. Boom. We probably don't need to put all of that down. But I think, as I was saying, first 2 bullet points are pretty key. Part B. So therefore we know that x is distributed binomially, 20 and 0.2. Mean and standard deviation, we've done this before. MP is your mean, which would just be 4. And then standard deviation is the square root of NP1 minus P, which is the same as 4 times the square root of 4 times 0.8. And that's just 3.2. So the square root of 3.2. Which I'm willing to calculate for. Square root 5 over 5. We can put down an exact value up there. If I go to S to D, 1.7 something or other. What question was that? 11. Okay, and so the next question is question 12 here. Seems to be the last one. I think this one we are going to use our calculator. It should be fun. As in we're going to use it for using our statistics and our distributions, which I did explain in the lesson. We spent a good 20 minutes on that in class. So 24% of the visitors make it to the museum to make voluntary. 24% of visitors to the museum make voluntary donations. That sounds quite high. On a certain day, the museum has 175 visitors. Find the expected number of donations. So 175 times 0.24. You can straight away tell I'm just doing NP, which is my mean or my expected value. So 0.24. It's 42. So B, find the probability that there's less than 40 visitors that make a donation. So X is distributed binomially, 175. Probability they make a donation is 0.24. So in our case here, P of X is less than 40 visitors make a donation. Less than 40 means that we've actually got P of X is less than or equal to 39, which is what we need for our probability distribution. So let's do this now. So on your Casio calculator, if you have one of these, if you don't, then it'd probably be slightly different. But we go to main menu, we go to statistics, which is the one with the 2 next to it. And then on statistics, we click on distribution, which is F5. So stats F5, which is our distribution. And then after F5, we're going to click on binomial, which is F5 again. And then after that, for this question, what we need is we need the cumulative, and that's the one with the C in it, so BCD, so that's F2. CD is what it says on my calculator. And then in our case here, we're going to do it with variable. So then you click, boy, we're going to run out of space here. Who would have thought that you have to press so many buttons? And then we're going to click F2 again. And that says var, or variable. And we're working with discrete random variables, so expect you're going to be using variable a lot more than you use the list function. So let's put our values in. So mine says variable. My lower bound is 0, because discrete random variables, you can't go below 0 number of trials. My upper bound here is going to be 39. And then my number of trials is 175. And probability of success is 0.24. Execute. And so when I execute that, I get P of x less than or equal to less than or equal to 39. Remember, that's what we're looking for, is 0.3336 ... which is the same as 0.334 to 3 s dot f dot. Part C. This is probably the most important question that I'll go over in this video. Between 50 and 60 visitors inclusive, so that means it includes 50 and it includes 60. So we look for P of x between 50 and 60. Well, what's that really saying? Because we can't really put that into our... Oh, we can put that into our calculators. I was going to say, technically, back in the day when you didn't have a calculator to do this for you, you would have to write down P of x is less than or equal to 60 minus P of x is less than or equal to 49, because everything less than 49 we don't need from the 60. But your calculator does it much nicer, because after we go through all of this, all we need to put into our calculator is, if I go exit from my previous one, is my lower is going to be 50, and my upper is going to be 60. So 50, 60 inclusive. Cool beans. And so if we put in lower as 50, and we put in upper as 60, and then we click execute order 66, we get 0.0930765 ... And so that in our case is just 0.0931. Okay, well, I hope we found that video helpful. I would say that past paper questions in regards to these are quite different, but that's an introduction from what it says from the textbook on this topic. Not an introduction, sorry, problem solving from the textbook, from the review section. So if you want to go through those, you're very welcome to, and you can go through some other ones on there before building up to part